Okay, I'm actually going to start recording for this segment. So USB 3 is not the only solution that is needed for webcams, because we had webcams that were like that. The Intel RealSense kinds of cameras were USB 3, and they could do 1080p 60 and some more uncompressed formats and things like that. The issue is you still have the processing power required for it, because for a webcam, if I grab... Nope, that's not going to work. Where are my other webcams? Okay, I just made a big mess of cords. Big mess of cords here. So here is, if I can figure out how to move the privacy filter. Hello? Hello? How many stream professors does it take to use a webcam? There we go. So this is the AverMedia live streaming webcam. It's a new webcam they released. This one's only USB 2.0. But let's for a moment pretend that it was USB 3.0 capable and it could send, 1080p 60 uncompressed feed like I keep asking everybody for. The problem is not the bandwidth necessarily. That's one problem of cheaper webcams that also adds to the cost. Then you have teeny tiny sensor that's the size of this pin dot. It's smaller than what's on your phone. Now, you could say, okay, sure, take bigger sensor from phone, smack into webcam. That's another problem addressed. That's not all of the problems addressed, because the next problem being addressed is that you need the processing power on board of the camera in order to process the signal. The camera I'm using now, the Sony a7S II, the camera in, my big cinema camera, all of them have processors that are directly connected to the camera sensor. It's literally like the camera sensor strapped to a computer. If you've ever seen any prototypes of the Red cameras when they were first being made, it was literally they had a desktop computer with big ass wires running to the camera sensor. You need that processing power to actually debayer, process, and handle all of the processes, for lack of a better word, of using a camera sensor and a camera to actually turn it into usable video feed, send it over that USB 3, USB-C, whatever wire into your computer. In fact, a capture card doesn't even do all of this work. It simply takes an already digitized video signal and converts it even more to a computer-friendly format. You can't do that in this tiny of a body for any cheap of a price. And as Jay Brucifer is bringing up, this is why the camera that I did review that was $800, the Sub 2R camera, is so expensive, because they have a full camera sensor, ASIC there, and then they have an FPGA chip, which is a dedicated processor on board to handle all of this control of the camera sensor that is in the camera. That's also why the camera is $800 and seemingly much more inaccessible to your average streamer. Now, you may be thinking, okay, well, phones just have, essentially what would be like a computer processor in it. Why can't you use that? Well, that's because the camera and the camera sensor are directly tied to the cell phone's processor. The cell phone processor in this instance actually acts as if it's the camera processor. There is a direct interconnect between the two, and they act as if they are one in the same, as if the processor, the Exynos or the Snapdragon or whatever is in your phone, is basically acting as if it's the onboard processor for the camera in your phone. This is why you don't see phones with the same processors in them, like something with the same processor as my Google Pixel 2 XL here, getting a crazy big fancy camera. You see cell phone cameras upgrading at the same time as processors, and pretty much the same cell phone quality cameras are tied to the same processors because they are, linked in terms of upgrade cycles. You can't send that kind of data over a USB cable, even USB 3, for your computer processor to process, and it's not built in that same way. There aren't instruction sets designed for your computer's processor to handle camera debayering and all of that. That's not a directly software process in the traditional sense. You can't just have a program that translates all of that and does all that work. And the latency involved between just going through USB and connection and USB drivers, as well as having your more standard desktop processors, are actually really slow at doing anything. Between the slowness of your processor and the latency of USB and USB drivers, you would not have a usable real-time image for such a thing. So overall, there isn't really anything to go with. The Captain Howdy is asking about a middle ground. that is a real camera with a capture card. That is the Sub 2R, which is basically a real camera just built specifically to connect over USB or the network as a webcam with their own FPGAs or ASICs. The middle ground is products we have and products that are coming out, but are inherently more expensive because of that option. So you have cheap mirrorless cameras like the A5100 that I'm always recommending, the Panasonic G7, the new Canon M200 that I'm still trying to get my hands on for a review. Those are cheaper real cameras that you then strap with a cam link or a deck link or something like that to capture it. But ultimately, it's still its own dedicated camera, and you have separate camera processing and video capture processes going on. And that's fine. Like, that is what, if you have the needs that those cameras solve, those are the products for you. The Sub 2R is pretty much the only middle ground you can get for that, because it is that weird hybrid of a real camera / webcam combination. That's the only one that really exists, at least on a more consumer-facing market, and it's the only one that probably will exist for a while because, again, for $800, you can go buy a pretty awesome mirrorless camera and a cam link or whatever and hook it up to your computer and be better off, or at least just as good off. The problem is people want that whole package in the same package as this, a super tiny $40 product, which just cannot happen. Physics, costs of manufacturing, just everything about it, it just doesn't work out.